Hi everyone, welcome to MathSpellBook. I'm your host Peter, and basically we are going to engage with more function-based proofs. So I was doing some this morning, so I'm starting to get a little bit of an idea of what we should do for these proofs. So, but doesn't mean I fully understand them yet, but it feels like I'm starting to get an idea of exactly what is it that we need to actually apply to each of these proofs. So that's basically what we're planning to do today. Hopefully we can get a bigger understanding throughout the stream to understand it. So off stream I do study this material too, so I try my best to at least apply what I've learned. Oops. Paste that. So, but how are you guys doing? It is Tuesday. Hopefully you guys are doing well. Alright, so prove that the function... Okay, so we can't have it at 1 because it's a fraction here, so... Alright, so proof... Suppose x prime are elements of the reals minus the set 1. Alright? And f of x is equal to f of x of x prime. Alright? So now put a period there. We shall now solve for x. So we have x to the first, x to the 1, and that's equal to x prime plus 1 over x prime minus 1 to the third. So now we have to take the third power I don't know why I was putting I was gonna write a 2 there. Okay, 3. Put this down a bit. So now we have x prime plus prime. And I think we just multiply these terms here. Okay. In doing so, wait, hold on. This is x prime here. Don't want to mix those up. So we have x and x prime plus do x prime minus x, and then that will be negative 1. And then this side we have x prime with x, and then x minus x prime, and then minus 1. Okay, so doing this, we know that these will cancel out. Just want to make a double check here. So that's going to go into that, that's going to go into this. So therefore we can can take these out. So then we're left with these two will cancel out. Yeah, because then we add that one on that side. So we're left with minus x, and then x. All right. So then we're left with, so we do this, that'll leave us with 2x prime on this side, and then 2x on this side. Therefore x prime is equal to x, or x is equal to x prime. Okay, so now suppose, because now we gotta do it, oh hold on, I gotta check here, because it has to be from the same set to the same set, so, but that doesn't seem to violate, yeah, because we have a perfect section here, so now we have to double check here. So we just can't have one, so suppose, oops, B is an element of, well actually let's put Y. Y is an element of the reals minus 1 and f of x is equal to y. Alright, so hence, so if we solve for x, I think we're gonna do the scratch work here, so x plus 1, x minus 1 to the third equals y. That means we gotta take this side and then let's move this over here. Then so meaning that we can shift all this on one side here. So we get 2x. Yeah, because we have to minus this x on the other side. We get 1. Then we can remove this x, like so. Left the 1 here. Therefore, x is equal to 1 over y to the cube. So x is equal to because minus this and yeah, I think that's okay. So now we substitute of x. Or I should put f of x equals y. So that means we have plus 1 and minus 1. That's all to the third power. That doesn't look neat. So just like that. Okay. And this is all equal to y. This should be fun. So we're left with the hard part. Well, actually, let's just simplify this more. So we have 1 plus this one, just have 1 minus this. These two out. And now we're left with technically we could have just merged these two. I just realized what I could have done. So we're left with, no, actually it should be 1. This one should be minus 1. And this one should be it's like so minus 2, minus 2. That will leave us with negative to the third. should rewrite it as now I'll leave it the way it is. Okay, I think now it's like scratch work at this point. So these two first, and then we can multiply. So this equals y. That we have minus y plus 2 minus 1. Then we have 3y, then 3 cubed. Okay. Okay, the other one. Just drag it to the side here. So yeah, I think we can rewrite this as 3 minus, just to make it easier, so we can do it like this, like so. Then we're left with 9, then minus 3, then minus 3, and then these two together make positive y, and we get 9 minus 6 to y cubed plus y, and then after that we have to multiply the last one, which is okay, so multiply that by 27, 18, and then negative, then 6y, and then minus, okay, 27, plus 9, y, and y. Okay, so it's 27 minus 27 y cubed plus 9 y minus y. Okay, going. And hopefully we get things that cancel. So we get minus 3. Yeah, because y comes out of there. Then maybe that's the wrong grouping. Let me take a look here. Because we got y here, 1 minus. Becomes negative. Yeah, because it becomes like right here. Yeah, that becomes negative. So then that's negative 1. So yeah, that is correct. Okay. Let's see. I think we should rewrite the like terms together. So we have 2 y's here. But we can't combine these. We got 1 here. Yeah, this minus 1 is kind of in the way, but depends on how we take this apart. So this one's 9, so I think maybe we should. This is 27 here. It's just that there's so many ways we can group it. That's the one thing I have to figure out. Because we have like 3's here. We also have y's in here. Because we want it to equal to y, so maybe we can cancel out the trying to make sure I did this right. No, that looks about right. If you take the y out, minus plus maybe taking out maybe y to the cube is easier, so maybe it's not subjective. But it says prove that it's bijective. Yeah, defined by is bijective. So that means it has to be bijective. Let me see if I did anything wrong with my algebra here. Here, it's supposed to be this. That's probably the reason why. And let's erase this part. So yeah, I think that's what I did wrong. Erase all this. What we did wrong. Alright, so now I think what we should do here is that plus like so, and then we have x on this side, and then we can factor out x, leaving with and then this would be minus 1. Okay. Yeah, that's what we're looking for. Okay, so that's why it was off. I was like, so erase this. X is okay. So now this one. Okay. Now the fun part, doing this all over again. So we'll do the scratch work here. So therefore we got 1 here, and then we're going to get 2 here, and then these together will make y, and then we're going to multiply this by the last one. Down here, so then we got the same one up here. Then we're going to get Q Oops, there we go. I was like, why does that look funny? And then plus y to the y cubed. Put that all together. This is 3 y cubed, and then 3y plus y to the y cubed. All right. Next. We gotta do y cubed. So we'll do it by this way. Then we're left with y. Then minus the cube. And then plus 1. And then after that, we gotta do this again. So y to the cube minus 2 to that, and then plus cube. Okay, next up, what is that? Together, we get minus 3 plus 3 minus 1. So that leaves us with plus, and I think for this one we can rewrite it, so put negative 1 actually plus 3 cubed. So practically they're kind of like opposite, almost like similar, it's just that two of them have the signs different. Yeah, because it's like one is plus and one is minus, so that's probably expected. So now I think we're gonna have to do it by grouping, I think. Yeah, I think grouping is probably gonna, so we can put these two together, and then we can put these two together. Then we can do the same thing over here. Then plus this, and then add them together, that's -2, right? And then that's positive. Then we multiply this one, yeah, and that would come up with that. And then right here, yeah, that would be -2y. Then, yeah, that would be positive. And then we do, so it's a -y, +2. Math checks out on that one. Now for this one, that makes 1. Then, yeah, that makes 2 right there. Then makes that y, and then we multiply this. So then that turns out to be this, the same one. Then we multiply this with this one. Multiply with that. Then you get the 2y. And then like that. Okay. Oh, maybe I did this the wrong way. Because I just saw that there might be a simple trick. There might be a simple trick I could have done. So let's get rid of these first. Because I just remembered something from basic algebra. Let's cover this up. No, not like that. You guys probably have already saw it too, but I was like, oh wait, why am I working so hard when, if it's like that, then maybe I could do something. Or maybe I'm just erasing it for no reason, but I just feel like maybe this is, this might be an easier approach. Might be an easier approach, or I'm just overthinking things. Because if we have this one minus 1 to something else. I just realized why it's not gonna turn out the way I want it to. It's not going to turn out the way I want it to. Because I thought I can, because I thought of 2 squares and I'm like, no wait, that's the wrong way of thinking of it. I was kind of looking at it the way I was thinking of something like this. Like, you know, like when you just separate it, like, you know, like one side is like, say, like plus, and then this side would be like minus 1. I was thinking of something like that, but I don't think that that's going to work in this scenario. Because something has to cancel in here. And plus the parentheses are around this whole thing. If it was individually, then it would work, but it's not. it's supposed to be bijective, so I think it's just tedious. It's like rigorous and tedious. Well, I don't know if rigorous would be considered synopsis with tedious in mathematics, but it does feel that way. Check to make sure that that is the question. Okay. To this nonsense again. together, it's like hold on, I think I made an error. Yeah, I made an error. I think it's supposed to be, yeah, because like we're missing the Y in here. That's why I got mixed up. I was like, that's not right. Because right here, it's supposed to be Y here. There we go. So that's how it's supposed to be. The one issue is this part here, because like it's just a negative version of this. Because we can't just because we can group these 3 plus y, and then for this one we can group it like this plus problem is, yeah, if this was like, it would be 1-to-1, but I don't know how that's supposed to make sense here. Maybe it's not subjective, but it has to be subjective. Because we did prove that it's an injective. Proof it's injective, so proving that it's surjective is just very tedious. It's just like I'm like trying to figure out exactly like what is it that we're missing here, unless we had to like rearrange it so it's like but then it's like negative over positive. So what is it that I'm missing here? Because this is just a negative version of this. So I'm like, why is it that this problem is what, number 10? So let's go back to the table of contents, exercise 10. So we did prove this one. So we proved that it's injective. Now the thing of it is that for surjective, what are we missing here? Oh, maybe I missed something in this step. So let's take a look. Okay. Yeah, because the way we do it is that minus here, and then this one has to go on this side, like that, and then we just remove x like this. I mean, it's still pretty much the same. Yeah, it's still pretty much the same. I missed something here, because like, alright, let's just do this over, because for some reason I think I'm just confusing myself by looking at the algebra, and I'm like, maybe there's something in the algebra I missed. So then like here, then erase that, put that over here, and then minus. We have x here. Then this would lead us to x minus x here. Then that also would equal to plus 1. Yeah, because this is minus, so it would have to go to this side. And then minus 1. So maybe we have to convert this one, so it's like 1. So that'd be negative 1, and that'd be negative, so maybe that's the trick, like basically just minus, then minus 1. portion. So somehow this one is, well, technically it would be like this. And then that would, I mean, that would reason why it's positive. And the bottom would be negative right here. I'm like dissecting this like a lot, so it's like, okay, so minus, yeah, the minus there. And these two go together like that. And then one. At this step, one plus now the one thing I'm not understanding is that just drag this over here. Looks like. Then we subtract this side into this side. Well, add this side to this side, and then minus this side to this side. I think the reason I'm getting so confused is because like I'm trying to figure out how they came up with this part. Because you multiply that side and then minus that side, and this one is just minus this, which is what we did, yeah. Because like this side was one, and then move the x over here. This side and minus the x over there. So I'm trying to figure out why is it that, unless they did it like, I mean, I don't think that should matter though, but why? Why does that feel so strange? Because the way I'm thinking about it is that They did it in a particular way that it's like, why does that even matter? Because if you did it this way, where it's x minus x cubed here, and then minus this one, and then factor out thing is that I don't get why they did it this way. That's the one thing I'm not understanding. Does there exist in A such that... Oh, okay. As there exists such an A as B. Oh, so you didn't really need to write out all the steps for that. Okay. So as long as you basically got, like, I guess an answer. Dang, we did all this for, like... I mean, I'm not gonna say it's for nothing, but at the same time, it's like, I think because I was expecting to basically just prove it through, like... Maybe I should ask ChatGPT, why is it that... so, the problem we have here is 10, copy, paste, no. Alright, yeah, I'm just trying to copy from my writing software, but I guess I'm gonna have to do it the old-fashioned way. Take it like this, paste this, and why is it that I don't have... That's what I want to know. I just typed it in ChatGPT to see, because like I think the thing that's confusing me is like, why is it that like for the other stuff that we had to prove that B equals B for when we replace it, and for this one it's just basically we just get A and we're done. That's the one thing I'm like wondering. Because I already figured out how we did the the injective part. It's just the surjective part. I'm like wondering. Recall the difference, comparing arbitrary. Start with arbitrary input y inputs on here. We're constructing an input. We don't compare things. Hello, I see Nusen? Hopefully, I'm probably not reading that right. Hansinusen? Hans? Okay. How's it going? I see it's your first time in the chat. What's the best part of your day so far, Hans? Yeah, because right now I'm wondering, why is it that when we prove this, we don't have to implant this thing into to prove it? So let's see. Doing charity work? Oh, okay, that's good. What type of charity work? If you don't mind me asking. Voluntary? Oh, okay, I see. That's good. I mean, like, what are you volunteering for? I play games with kids. Oh, okay. Like video games? More like sports. Oh, okay. Gotcha. That's good. That's good. Helping out the community. Yeah, it's like, you know, like, because of like technology nowadays, gotta like basically get everyone outside. Freeze tag and oh, okay, that kind of stuff. Okay, gotcha. That's good. It's like helping out the community, basically getting the youth to go outside and touch grass. Especially with the amount of iPads and phones going out to like many young people. So let's see, subjective. So we proved, yeah, so we showed that x is valid and not equal to 1. Okay, so since okay, it's not equal to 1, and since if x is equal to 1, the denominator vanishes. Thus, every y has a pre-image. Okay. Why you don't show the first sentence? Because it is not about uniqueness of the outputs. It's about the existence of an input. Okay. Okay. So we have to show that it doesn't violate the set that it's in. Okay. That makes sense. Oh, it's inside a gym? Oh, okay. Well, I mean, it gets them moving at least. It's either gym class or like them playing outside. Are you into math, Hans? Because I'm guessing you're on our stream because you have an interest in math. A tiny bit. What math do you know? Oh, actually, Hans, I probably should ask, are you a student or you just like math as a hobby? Or do you use math in your daily job? That could also be another thing. Okay, so I guess that's something to learn, is that when it comes to surjectivity for a function, we don't have to prove that b is equal to b. I'm above my class, but it's still just 9th grade. A hobby? Okay. 9th grade. Oh, okay. Oh, from Norway. Okay. That's cool. Like, what type of maths are you learning? Like, is it like just algebra, pre-calculus? That's good. At least you're like trying to train yourself to learn like maybe math that you haven't touched yet. So I think that's really good. Okay. so we spent most of our time on this one. Just one problem, so let's see if we can do 11. I don't know if 11 is going to be just as effective, but now I don't know why this is doubling up all of a sudden. Okay, consider the function. Okay, so from 1 and 0, sets of 1 and 0, with the natural numbers to the integers as, oh, okay. Is theta injective? Is it surjective? Is it bijective? Explain. Okay. I have made my own kind of pattern. Kinds wanted to see how fast people would recognize the pattern. Oh, that's cool. Yeah, because like math is all about patterns actually. Like if you ask like someone like what is math about, they probably would be like, is it the study of numbers? I mean, like that's part of it, but not really. It's basically studying in patterns. Suppose so we have A and B here, so suppose A and B and A prime, B prime are elements of 0 cross product, Cartesian product of this, the natural numbers, and theta A B is equal to theta A prime and B prime. Okay, now we gotta prove that it's injective, or if it's not, so let's just see how it goes. Alright, so if that's the case, then A and B would have to equal A prime and B prime, right? So if you want, you could the pattern in chat, and you could try to solve it. It could be hard, right? I'm just like, sure. I mean, like, the thing of it is that, like, I mean, it's interesting what, like, people come up with in patterns. It's a lot of typos on my part. No, it's okay. Because you said you're from Norway, so I'm guessing English is not your first language. Okay, so if that's the case, then A. So now we have to do this, where it's like -1 A times B is equal to -1 A prime B prime. I'm just not used to typing on my phone and misclicks. Oh, okay. That's okay. My thumbs like hit the wrong buttons too sometimes. Okay. So because we have two variables here, and the thing is, whenever it comes to like double variables, like, because this one is going towards the integers, and have 1 and if it's 0 and 1. So if you put 0 and 1 in here, like 0, this turns into 1 and that turns into 1, but then it also has to do with the natural numbers too, so, and plus it's a -1, so I feel as if there's going to be a point where there's going to pair up somewhere, where it's like if you have, so if it's like 0 and 1, so it'll be negative something, and yeah, I think more likely it's not going to be injective, because if you're just switching between one, like if it's any of the natural numbers, like it's still going to be -1 or +1, and I think there's going to be a likelihood that one number is going to match, I think. Okay. Oh, you have a pattern, Hans. Let's take a look at what it is. Let's see, we have 30, we have 143. Interesting. Oh, 232. So I might as well write this down for you guys. Hans has just presented a pattern for us to check out. So might be quite a challenge. Oh no. Okay. So luckily I have my calculator next to me, so I don't have to do the arithmetic in my head. Interesting. Well, it's not obvious, so the pattern is not the differences. Well, let's see. This one's odd. This one's odd. This one's even. Even. Okay, so it's not their parity? I think that's how you pronounce that. That would equal 6, but if you add them together, it's 5. I'm I'll just put that there just in case. So if you do this, I mean, this would equal to 10. But the problem is that this equals to either 12 or 8. I mean, it's a fun pattern. I mean, this would equal 7, but with this O here, I'm not sure if you can convert that to a 10. Because then it could be 8. And then if you do these two together, it would be either 54 or 15. Huh. It's not like it's like 1, 2, 3, 4 or something like that, so that's not the pattern. I feel like I want to like take more time with this, so I'm actually going to copy the numbers you typed out, Hans, and I'm going to post it on my Discord for future references. So I'm going to be posting this in assignments from stream channel. So I'll just type in find the pattern in these numbers. And we'll paste that. Then I'll put that there so I can actually fixate on it. And thank you for the follow, Hans. Much appreciated. Hey Sascha, how's it going? How are your classes going so far? So I think I'm going to erase this. But thank you for the pattern, Hans. That's a pretty interesting one. Here the hardest part is to remember whether or not the book considers 0 as a natural number, right? But I think I'm starting to understand like the formation of these proofs though. I mean, I feel like now I have an idea of what to see for like, because before I remember I didn't know how to prove how a function was injective or surjective. Now I kind of have an idea and I'm like, oh, okay. Yeah, what surprised me was that the whole entire stream I was focused on this problem. And I was trying to prove that it was surjective, but I didn't realize that to prove that it's surjective, I didn't need to actually try to prove that y equals y. because I had basically suppose y exists in the real numbers and the minus the set 1, and I didn't realize that like you just had to prove this. You actually had to show that, you know, like x f of x, or the x in f of x is equal to something that's not 1. I wasn't like, I didn't think that that's how you prove it's subjective. I thought you had to actually prove that, oh, if you substitute this for x, you basically should get y. But like, according to what the answer is, you don't have to do that. And I'm like, oh, okay. I thought you had to do that for every time you try to prove it's subjective. Alright, so now we gotta prove that this is injective. How do we go about doing that? Because A is supposed to be the, a pair of the natural numbers and like 0 and 1. So basically, oh, maybe A has to be 1 or 0. So if A is 0, then basically it's going to be like -1. I mean 1. And then if A is 1, then basically it's going to be -1. So if B is the natural numbers, I mean, logically, if I think about it, if it like alternates, I mean, if you have B pair up twice, like say if you did like A is 0 and then, yeah, I think that would make sense. If you're doing like an ordered pair approach, it's like one pair is that it's 0 and another pair is 1. But then again, you'll be getting two different answers because it's like negative of the version of the number that you got. So if B was 2, but then A switches from A 0 to 1. So if it's 0, then basically it's positive 2, and if it's 1, then it's -2. So I get a feeling that it is injective, based on the way I'm thinking about it logically. The problem is that I mean, does that prove what we have though? Because it kind of shows that. Because I'm trying to think of a counterexample. If it's like, if you have 0 and 1 and it comes out with the same answer, and I don't think that's the case. So I think it's injective, but is it surjective? That's the real question. Because then it's going by 2 pairs, so I think in this case maybe 0 is not. I don't think 0 is included in the natural numbers here, I think. If it is, then that means it is not injective. But if it is included, then it's not injective. But if it is included, then if it's not included, then it is injective. Check at the beginning of the book. Because if they explain sets, then they're going to explain what the natural numbers are. Yeah, so natural numbers is... Okay. So at the beginning of this book, they basically said that 0 is not included. So I'm saying... So I think... Yeah, so I think it is injective because 0 is not included, so it's not going to be counted towards being B in this case. So I think it is injective. So I think we can write that in the proof here. Since theta is, well, actually, we should probably just put b, since b is an element of the natural numbers. Theta of a and b is injective. I don't know if there might be something more to the proof that we did, but we'll check that out like afterwards. Now, is it surjective? Okay, so suppose we have to suppose that this will equate to a result. So suppose that there's an element, let's call it z, element z in the integers, and z is, well, I should probably write this, that theta of a and b is equal to z. Alright, so that means we have to show that z so a is going to be either, so maybe we should try to solve for just b. So we'll say z is equal to -1 a and then b, meaning that b is equal to z Alright, now the question is that an integer? And if it's 0 or 1, it will be an integer because it's just -1. So we don't have to worry about like it being like some sort of weird fraction somewhere. Now, I guess we're gonna have to plug it in. And when you plug it in, it basically will give you, so we have z is equal to -1 a c, which crosses these out, and then you're left with z equals z. Thus, theta of a and b is surjective. Therefore, theta of a and b is bijective. Oops, not bijective, bijective. This is number 11. So let's check out solutions. So I think it's both. Hopefully we got that right. If not, then I don't understand the proofs that I probably should, as much as I thought I did. But no problem, we still learn either way. So this is chapter 8. Dun dun dun. 11. 12. There's 12. 12.2. Okay, so it is 11. So 11. Here we go. We first show that it's injective, then is as B and D are both positive and N, they're both positive because of which allows that have the same sign, since it's equal to +1 and -1. We implies that D equals B also means that they're the same. D because A and okay. Follows thus is so. Oh, it's not surjective. What did I miss? What did I miss here? Note that it's not surjective because it's either positive or negative, but never zero. Oh, okay. Yeah, that's right. Okay, so I guess I didn't fully understand the subjective part here. I think I have to learn more about surjective proofs because I'm like, I think that's like the 4th time I got this mixed up. Because I guess I'm just not thinking about the whole entire codomain. I mean, it is discouraging, but at the same time, I think that's the thing you end up learning when you're like trying to understand exactly what it is. Because I think I don't think of counterexamples that much because I'm just trying to write the proof and not focusing on anything else. But then I have to remember that, oh wait, there is math beyond. There is math that I know that's mainly in the calculation section of my brain. Yeah, because it doesn't include 0. If it was the natural numbers, it probably would have worked, but it's not. It's the integers, and I forgot that the integers also include 0. Yeah, because like B is supposed to be part of the natural numbers, and there's no way you can get 0 from that. I gotta do better job of seeing those things, because I think like I remember watching a video about learning, and I think the person that was like the host of that video, they basically say like there's a reason why you make these small mistakes, like the mistakes that you probably catch yourself making all the time, like forgetting a negative symbol or like, you know, the small stuff. And I think I'm noticing that I'm making the same mistake when it comes to looking at these looking at the domain and the codomain, because I'm not thinking about them whenever I'm doing the surjective part. Like, I'm not thinking about them deeply enough, I think. That's basically what I'm trying to say. So, this is wrong. I mean, at least we got it that it's adjective, but at the same time, it's like... That's part of the struggle with math, I guess. Alright, so... Let's see, that was 11, we're doing 12. Okay, consider the function theta. Alright, so I guess the awareness is actually coming into this problem because it's the same type of set. So, proof. Suppose A, B, and A prime and B prime are elements to theta A prime and B prime. Okay. So that means if they're all this, if A prime and B prime are the same, then they should like equate to the same thing. If you try to like solve for so A is supposed to be between 0 and 1. So if you have 0, so these will become 0 and B will become any of the natural numbers. So if you have 1, so it's either positive or negative. So I think this is injective because if you have 1 at A, and if A prime is also the same as A, so that means like, yeah, this will equate to like a negative number if it's 1, but if it's 0, then that means it's going to be a positive number. So I think that this one is injective. So it is injective. Now, for it to be surjective, can you get 0 from this one? Like, so it's like suppose Z is an element of the rationals, of the, not rationals, of the integers, and theta of A and B is equal to Z. So if it was to equal B, yeah, I think this one is not surjective because if Z can't be 0 at this point, because if A is 0 and Z is 0, then basically like that gives us an undefined answer. So I think it's not surjective. So let's see, not surjective, I think. So let's check out exercise 12. I'm understanding about 5% of the stuff that I'm seeing and hearing, but I don't mind. It's okay. It's mainly math proofs. It's introduction to math proofs, so it's okay if you don't understand like some of it. I mean, like, since you're from Norway, I'm guessing that like your math education is like much more advanced than the American system. For me, I'm just learning math on my own, and learning math proofs is a different type of mathematical muscle, and I'm still not used to it. Oh, it's not injective? What? Dang. Then I need a lot more work to do on understanding both of these things. And it is surjective. Oh my goodness. Dang. Yeah, there must be something that I'm not comprehending here. Guess we're gonna have a lot more work to do, like studying these things. Okay. So it's not injective, but it's surjective. Huh. Oh yeah, because if it is 0 and 0 equals 0. And this one, let's see, 1, yeah, 1 plus 2, and then 1 plus 1, yeah, okay. Yeah, so that's why it's not injective. Yeah, I didn't think about that. Shoot. Okay, that one I understand why I got wrong, because I didn't think of this example. I probably should have thought of that. This one, I'm like, I guess I was trying to apply what I learned from the last problem into this problem, but that probably wasn't the right approach. I mean, like, I understand why it was like that. Like the way it's set up, I think I kind of tricked myself because I was expecting it to behave the same way that this one was. But I guess like that's the reason why I didn't do well in this one. I don't think I'm supposed to understand this in 9th grade either though. Yeah, but at the same time, like, it doesn't, like, even though you're not learning in school, like, if you're curious enough, you probably will try to read about it at least. Like, sometimes waiting for your class to actually cover it doesn't really, like, it doesn't really, like, let you understand it as easily. Sometimes, like, when you learn on your own, it kind of allows you to like, get a little bit more experience with it, you know? I mean, that's how I feel about it. Okay. Well, that's the point of my streams, guys. Sometimes I get it wrong, so you don't have to. But, like, sometimes, like, I get it wrong a lot more times than I get stuff right. But I think that's the reason why I do these streams, is because I like math as a hobby, and obviously I'm not going to get every single answer right because there will be gaps in my understanding, and I'm pretty sure some of you guys probably have experienced that. If you're doing math or you're doing physics or you just love doing both of them at the same time, you will run into pitfalls where it's like, oh wait, I thought of this thing, but I didn't realize it. I didn't think of this scenario. But thank you for joining me today, guys. If you're watching this on YouTube Live, consider hitting the subscribe button and leave a comment down below if you'd be so kind to do so. In addition to, like, hitting the like button. All the links will be in the description down below for the Discord server, as well as like a link to my video game channel. If you're watching this on Twitch, thank you for joining me. Hit the follow button. I really much appreciate it if you hit the follow button if you want to keep up with me on my mathematical journey / physics journey. And I will type out the Discord server in Twitch so you guys can have access to that. And I'll also put my video game channel in there as well. So if you guys want to check out my video game channel whenever I play video games or whenever I do a podcast there, that is also fine as well. Okay, so I think that will do it for today, guys. We're probably going to get back into this so we can, like, learn more about functions tomorrow. So thank you for joining me today, and always remember, everyone is precious. You guys are just as precious as everyone else, and we will see you guys in the next stream. So take care, guys. Bye-bye.